we will find the Laplace transform for these problems. What we see here is if we have t to the n power times a function, what that affect the transform is it's going to be -1 raised to the n, which is whatever the power n here, and then we have the derivative of the transform function, meaning f of s. Right, and then of course all the formulas for Laplace transform. Right, so first we have Laplace transform of t to the first power here, so that t to the first power, which means we're going to have -1 to the first power, and then the derivative. Because this to the first power, we have -1 raised to the first power, and then the first derivative of the Laplace transform of cosine beta t. Alright, so we just negative, and then the transform, so inside the bracket, cosine of bt, we're going to use that, which is s over s squared plus b squared, and then don't forget that we need the first derivative. Sorry. And so we just use the product, the quotient rule here. I just keep the negative there. Alright. Will be derivative of s, derivative of the top, which is 1 times the bottom. Subtract the top with derivative of the bottom over the bottom square. And I just keep the negative outside here. Multiply inside, we should have s squared and then minus 2s squared. So that's right, s squared plus b squared minus 2s squared over s squared plus b squared square. Again, I just keep the negative. The top we will have negative s squared plus b squared over s squared plus b squared square. We can distribute the negative inside, will be s squared minus b squared over s squared plus b squared square. Right, so that's what we have. We have a similar problem, but this time we have t to the second power. So we will have the second power of -1, and then the second derivative of the Laplace transform of cosine bt. Right? So we have -1 square will be just +1. The transform of cosine bt will be just s over s squared plus b squared. Don't forget that we need the second derivative. Right. Good thing here is, well, we already did the derivative from the first part of the problem. And just be careful that when we talk about the derivative, it doesn't include the negative sign here. Meaning that the first derivative is equal to this one. So, meaning that instead of taking the second derivative here, we will just take the derivative of the derivative. Derivative is -s squared plus b squared over s squared plus b squared square. Now we just need the derivative. Again, that is also a product rule. On the top, derivative of the top, we have negative 2s, and then the bottom, s squared plus b squared square, and then minus the top, minus s squared plus b squared times derivative of the bottom, that is 2 times s squared plus b squared, and then there's a 2s there, that is the chain rule, over the bottom square, so s squared plus b squared square will be to the square, and then we square again, or to the 4th power. Alright, now focus on this problem. On the top, we should have, by the way, we should have s squared plus b squared. We should be able to factor it out. 1 factor of s squared plus b squared. What's left is going to be negative 2s s squared plus b squared, and then minus negative s squared plus b squared times 2s. I'll close the bracket there. The bottom is s squared plus b squared to the 4th power. We can cancel with s squared plus b squared on the top, and that's actually just down to 3. And multiply everything on the top. We should have negative 2s cubed, negative 2s b squared, and that will be 2s cubed with the positive side. And of course I forgot the 2 here, did I? Just put the 2 here. Alright, so that will be 4s squared times s will be s to the 3rd power, and then minus 4 sb squared over s squared plus b squared cubed, and combine the top. I think I just put the answer here. We should have 2s cubed minus 6 sb squared, and then s squared plus b squared cubed at the bottom. So that's what we have. So when we take the Laplace transform, when we have t to any power, that power will be the power of the negative 1 and the order of the derivative. So here we have the second derivative there. And that's what we have.